হ্যাঁ গোবিন্দবাবু, আমি সুদর্শন বলছি আইব্যাক থেকে। বলছি আপনাদের ওখানে আজ আপনার অঞ্চলে আজকে কোনো সহভোজ হচ্ছে নাকি? মঙ্গলবার হবে না? তাহলে ঠিক আছে। হ্যাঁ হ্যাঁ হ্যাঁ, সেটাই বলছি, কারণ ওখানে গিয়ে ফটো নিতে হবে, নইলে পরে টাকা পাওয়ার ব্যাপার আছে। ঠিক আছে, ঠিক আছে, ঠিক আছে। ও, ও। अरे मोना, तुम सच में रो रही हो क्या? तो रो क्यों रही हो? गाड़ी ठोकना तो तुम्हारा कोई वैसे थोड़ी ना है। अरे ऐसा मत समझो भाई। मेरा स्टार्ट हो गया ऑलरेडी, कोई एक ज्वाइन करेगा तो मैं स्टार्ट कर दूंगा। तूने अभी तक ज्वाइन नहीं किया तो मैं वेट कर रहा हूँ। मैं परमिशन ले लिया हूँ, आज ही मेरा लास्ट क्लास है। तो अगले क्लास से मैं नहीं लूंगा। बोल दिया मैंने, आई एम विद एक्सपीरियंस आई एम अनेबल टू, मतलब फील वो करते हैं जो भी है। मेरे को लगा तो सच में रो रही है। आज किसी ने बोला आज किसी ने नहीं, क्योंकि आज रात को अच्छे से पेन हो, उसके बाद स्टार्ट। अरे यार ऐसा ठीक है, मतलब देखता हूँ उसको पहला रहेगा, उसका आगे आगे कुछ नहीं ले, मजा लेगा ऐसे ऐसे। हाँ एकदम। वो भले ही बोलो कि जब मेरा वो हुआ ना तब ऐसा हुआ। मेरा जब कार क्रैश हुआ था तब ऐसा हुआ था, ऐसे बोल, अगर बोलना भी है किसी को तो मेरे को जब छोका गया था तभी ऐसे हुआ। क्या अरे मेरा भी ऐसा नहीं पूछूंगा पता है क्या वो हाँ ये भी ऐसा हो रहा है this is a very disappointing situation I know that but what to do there is a thing sometimes wait हाँ कोई नहीं join किया अभी तक so sometimes things are within your control sometimes it is not तो कोई मेरा सर्कल में बिजनेस होता है कोई सर्कल में फिर मैं जितना मेरा टाइम लिमिट वो टाइम में जितने को मैं बोल पा रहा हूँ उसको मैं बोल रहा हूँ तो उसके बाहर जाके कुछ ऐसा हो रहा है सिचुएशन मतलब क्या कर सकते हैं। जिनको 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 संभव है उनको उनको मैं बोल दिया हूँ आज के आज एक का ट्रेनिंग का बात कर रहा था तो उसने बोला कि उसने कुछ बताया ही नहीं बस ऐसे डिस्ट्रीब्यूट कर दिया दोनों का देखो, तो उनका कोई असिस्टेंट आया था उनको मैं बहुत अच्छे से समझाया इसको पूरा बैग ऐसे 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 दे रहे हैं तो फिर जो मेरा आता है उसको डालो क्या मजाक उड़ा रहा है ये उसको दे रहा है हाँ एकदम कल जाओ उधर जाके एकदम अच्छे से फेल किया अच्छा प्रेसिडेंट जो है ना उसको अच्छे से फेल किया ताकि वो प्रेसिडेंट को अच्छे से फेल उस वाले कैसे सुई सुई बातें करके बात कर रहे एकदम सीरियसली बोलो क्या बात चल रहा है आपका नाम आएगा ऊपर आपका नाम आएगा ऊपर रिपोर्ट में अब समझ के रख दीजिए ऐसे बोलो पर यार मेरे आज कोई ज्वाइन नहीं कर रहे मेरे को ऐसे ही स्टार्ट करना पड़ता है ऐसे स्टार्ट कर देता हूँ हाँ রসিক বলো হ্যাঁ কিসের কথা হ্যাঁ 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 ঠিক আছে তোমার তোমার অঞ্চলের এসিপিওসি কে মানে পিওসি কে তোমার তোমার দাঁড়া এক মিনিট আমি ভুলে গেছি তোমার কোন ইয়ে যেন এক মিনিট আমাকে ওরকম বললে মাঝখান থেকে বললে তো হবে না দাঁড়া, এক মিনিট, তোমার পিওসি কে হুম बोलेरो তোমার এলআর কে বলো না। এলআর এলআর নাকি তুমি নিজেই এলআর? দাঁড়াও, ভুলে গেছি। তুমি তো জিআরএম, তোমার এলআর কে? প্রলয়দা তো, প্রলয়দা তো, হ্যাঁ, তো প্রলয়দাকে বলো। হ্যাঁ। হুম। ব্যাস ব্যাস ব্যাস। হ্যাঁ হ্যাঁ হ্যাঁ। ঠিক আছে, তো প্রলয়দাকে তুমি বলো তোমার। হ্যাঁ, এই যে রশিদ খান। তুমি মালের, তাই তো? হ্যাঁ, মোনাকে বলো, মোনাকে বলো। মোনার নাম্বার আছে তো? মোনাদি নাম্বার নাই? ঠিক আছে, তাহলে প্রলয়কেই বলো, প্রলয়দা বলবে। ঠিক আছে, তোমার যে নাম্বারটাতে রেজিস্টার করেছো সেটা প্রলয়কে বলো। প্রলয় ওকে পাঠিয়ে দেবে। ও হিমাংশুকে পাঠিয়ে দেবে, বা প্রলয় ডাইরেক্ট হিমাংশু পাঠিয়ে দেবে, অসুবিধা নেই। ঠিক আছে, প্রলয়দাকে বলে দাও, হ্যাঁ। হুম 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 হুম। वो उसका नंबर यूपीआई रजिस्टर्ड नहीं था, रजिस्टर किया है, प्रोडक्ट से मांग लो। अरे यार, मेरा कॉल ड्रॉप हो गया। हाँ हाँ हाँ, ठीक है ठीक है। उसका नंबर जो है वीडियो वैन या बोलेरो किसी एक में तो है। उसका नंबर रजिस्टर नहीं था यूपीआई में, तो रजिस्टर कर लिया उसको। वो मतलब पूरा से ले लो, उसका नंबर रजिस्टर। वो उसका पेमेंट जाने के लिए उसका नंबर यूपीआई रजिस्टर्ड था। वो मुझे पता, वो एक बार पूछ लो। मेरे को रशीद खान ने कॉल किया, नेता बना था ना सबका, देख रहे थे सब पूरा बोले, तो इसलिए रशीद खान का नंबर। हाँ, उसका यूपीआई आईडी ले लो और हिमांशु को दे। उसका यूपीआई रजिस्टर नहीं था तो रजिस्टर किया है क्या, ऐसा बोलो। ठीक है। साला क्लास में कोई जॉब नहीं करता। कोई बात नहीं, ऐसे ही रिकॉर्डिंग करके छोड़। Okay, so I don't think anybody will join today, and I can just explain for the sake of recording. It will be because if there is no introduction, it will be over very soon. So let's start. So my name is Shutanu Sadhukan. I am a teaching assistant and PMRA student at IIT Bombay. I welcome the audience in the 10th interactive session, weekly interactive session on Sunday of the NPTEL course C39. with the course title Water and Wastewater Treatment 2024. Instructed by Dr. Bhanu Prakash Bhelanki, who is an environmental engineer from the Department of Civil Engineering at IIT Roorkee. Where are we? Today we are at the week 10, that is 31st March, and due to actually I will not be taking the next 2 weeks lectures, so only up to 10th. So there are two more TS, so they will be taking the rest of the 2 sessions. They can attend, the audience or the students can attend those sessions, and everything that is not covered till now, that will be covered within those 2 sessions. Okay, so let's start. Just for the sake of recording, we'll be doing. Nobody is there, so I'll just go through the questions. It will take 30 to 40 minutes to complete. I'll just record the entire session so that people can watch it later, and I'll share the slides. Okay, so the first question starts with the column matching. We have to match the left hand column with the right hand column. Within the left hand column, different pH values are given. So pH 11.5, pH 10.5, pH 7.2, and pH 4.1. And in the right hand column, the phenomena are given. In which pH, what is the phenomena? So option A is the predominant species of carbonate is H2CO3, that is carbonic acid. B is removal of calcium ions, calcium cations will typically occur as calcium carbonate on addition of lime. C, removal of magnesium ion will typically occur as MgOH2 on the addition of excess lime. And D is the predominant species of carbonate is it is the bicarbonate ion, HCO3 minus. So basically there is a mistake here. So the 3 will not be a superscript. It will be a subscript. Okay. So the correct answer will be something like this. So at pH 11.5, removal of magnesium ions, magnesium cations will typically occur as magnesium hydroxide on the addition of excess lime. So if you add excess lime, the magnesium cations will precipitate in the form of magnesium hydroxide at pH level of 11.5. Now at pH level 10.5, removal of calcium cations will typically occur as calcium carbonate on addition of lime. So if you add lime, calcium cations will be get precipitated in the form of calcium carbonate at a pH of 10.5. At pH 7.2, the predominant species of carbonate is the bicarbonate ion, that is HCO3 minus, and at pH 4.1, the predominant species of carbonate is the carbonic acid, that is the H2CO3. This is the reason for which the normal water, if carbon dioxide is stripped out, there are certain degassing devices in water treatment plants which actually strips the carbon dioxide with the help of water. But in the process, if the carbon dioxide gets dissolved inside the water becomes slightly acidic. So this is what it is shown here. So pH 4.1 is basically acidic. It is around neutral pH, and the precipitation of cations in the form of hydroxides or carbonates. These are the bicarbonate. These are basically bivalent ions, uh, which causes the hardness inside the water. They occur at the basic pH level, that is 10, 11.5 and 10.5. Okay. So next there is an MCQ. Which of the below agencies were set up in the pre-independence era? Option A is National Water Mission or NWM. Option B, Central Water Commission, CWC. Option C is National Rural Drinking Water Supply Program, that is NRDWSP. And option D is Central Groundwater Board or CGWB. So the explanation is as follows. The Central Water Commission CWC was set up in 1945 with the responsibilities of coordinating with the state governments and conducting awareness programs for control, conservation and utilization of water resources. So the answer is CWC or Central Water Commission, which was set up in the pre-independence era. All the rest of the organizations or agencies like NWM, NRDWSP and CJWB, these three agencies were set up in the post-independence era. Now next MCQ is lime is not required to remove option A calcium non-carbonate hardness, option B magnesium carbonate hardness, option C magnesium non-carbonate hardness, and option D is calcium carbonate hardness. So the answer is calcium non-carbonate hardness. Lime is not required to remove calcium non-carbonate hardness, but in all the other cases, magnesium carbonate hardness, magnesium non-carbonate hardness, and calcium carbonate hardness, lime is required to remove these three. Okay. So again, there is a column matching. You have to match the following policies or programs given in the left hand column with their target sector given in the right hand column. So in the left hand column, the policies and or programs are given, which are as Sajal Dhara, Swachh Bharat Mission and Catch the Rain. In the right hand column, their targeted sectors are given: sanitation, storm water harvesting and domestic water supply. So the explanation is the Sajal Dhara scheme seeks people's participation in the management of their water supply. Swachh Bharat Mission program was launched by the Government of India, aimed for making the streets, roads and offices clean from filth and garbage. Ministry of Jal Shakti launched the Catch the Rain campaign with the tagline "Catch the rain where it falls, when it falls," to nudge the states and all the stakeholders to create RWHs, which is nothing but rainwater harvesting structures suitable to the climatic conditions and subsoil strata, with people's active participation. So the Sajal Dhara Karmasuchi is related with the domestic water supply, Swachh Bharat Mission is related with the sanitations, and Catch the Rain is related with the stormwater harvesting. This is the correct order. CAB. Okay. Now you can see what is the difference between rainwater and stormwater. If people attended the session, I would have asked them. Otherwise, I'll just tell the difference. So rainwater is both are basically the source of both rainwater and storm water are basically rain. But rainwater is the water which is directly falling from the sky and we are catching in some RWHs or rainwater harvesting structures. But stormwater is something, if the rainwater is rain is falling from the sky, going to the drain and coming out. So within the drain, many dusts and uh, leaves from the tree and many other polluting things are getting mixed with the rainwater. So whenever that water is collected somewhere, that is called as the storm water. So if you are considering a ZLD, that is zero liquid discharge plant, so only the water that is taken for the use of the plant and that is actually recovered by means of certain treatment methodologies or treatment schemes, those water only actually considered for zero liquid discharge. But this storm water that is coming through the rain inside the plant and going outside the plant through the drains, even if that is going outside and that is not getting treated or used, that is not considered under the zero liquid discharge thing. So the storm water that is naturally coming in and naturally going out. So even if that is going out of the plant, that plant may still considered to be treated as a zero liquid discharge plant or ZLD plant. This is the basically difference between the rainwater and the storm water. So next MCQ is simulating and promoting the development and application of irrigation, drainage, river training, and flood control techniques comes under option A, INCID, that is Indian National Committee on Irrigation and Drainage. Option B, PMKSY, that is Pradhan Mantri Krishi Sanchay Yojana. Option C, RIP, that is not rest in peace. It is River Interlinking Project. And option D is MNP, that is Minimum Needs Program. So the explanation is to simulate and promote the development and application of irrigation, drainage, river training, and flood control techniques is one of the major objectives of INCID, that is Indian National Committee on Irrigation and Drainage. So option A is the correct answer in this case. Okay. So next MCQ is, which one of the following is the correct criteria for effective water softening? Option A, lime dose provided is less than equals to total alkalinity plus dissolved carbon dioxide. Option B, lime dose provided is less than total alkalinity plus dissolved carbon dioxide. Option C, lime dose provided is greater than equals to total alkalinity plus dissolved carbon dioxide. And option D is lime dose provided is greater than total alkalinity plus dissolved carbon dioxide. So the correct criteria for effective water softening is when lime dose provided is greater than equals to the total alkalinity plus dissolved carbon dioxide. There will be a bit excess lime or it may not be true. So this is the criteria for effective water softening. Option C is the correct answer. Slides are not changing. I don't know. Maybe because nobody is attending, my screen is getting recorded, so there is no issue. Even if the slides are not changing. Okay. If somebody joins in the middle, we'll see. Thank you for joining. Welcome to the session. I have covered almost 50%. So only maybe more, not more than half an hour is left. So you can attend the rest of the session, and the slides I'll be uploading in the in the portal. Okay. So this was one question actually. So which one of the following is the correct criteria for effective water softening? So where lime dose provided is greater than equals to total alkalinity plus dissolved carbon dioxide. This was the correct answer, and the rest are incorrect. Okay. So now I'll just wait for some minutes for you to answer from the next MCQ onwards. So which one of the following commissions recommended to make water as a union subject? Option A, Sarkaria Commission. Option B, Punchi Commission. Option C, both Sarkaria Commission and Punchi Commission. And option D, neither Sarkaria Commission nor Punchi Commission. So this is my last class basically. From the next week, only 2 weeks are will be left. So there are two more TS who will be taking who are also taking the classes. So the next two classes I will not be able to take. So I this is my last class basically, and the rest of the sessions, that is the 2 weeks. Whatever Saturday we will discuss, Professor Bhanu Pratap Bhelanki, whatever we will be discussing in the next two sessions. So that will be basically the MCQs and the problems that will be based on these two lectures that will be covered in the next two classes by the rest of the two TS. So this is my last class basically. Okay. So let's move on to the answer. I will not make you wait much today. So maybe on or before 8:30, today's session will be over, and I will be uploading the recording and the slides. Okay. So explanation is both Sarkaria and Pucci commissions were unable to suggest that water would be made as a union subject. However, regulation of water use is required. So neither Sarkaria Commission nor Punchi Commission is the answer. None of them recommended to make water as a union subject. But regulation of water use is required, that they suggested. Okay. Basically, water research or wastewater treatment, it is basically an interdisciplinary subject, not dedicated to any particular discipline. Okay. So now, next, what happened? Okay. So now next you have to identify whether the following statements regarding NWP, that is National Water Policy, are correct or not. Statement 1 is highest priority allocation should be for environmental needs to maintain environmental flows. Statement 2 is water institutes should be restructured and made multidisciplinary. So what is environmental flow or e-flows basically? If there is a river that is flowing from the source to the region from where it meets the sea, then what happens if there is certain industry or very huge population that is located at the upstream, then they will use up most of the water by putting dam or something for irrigation purpose or whatever. But what will happen in the process, the downstream portion of the river will get dried up. Okay. So there might be certain other populations who are living in the downstream banks of the river, right? Their livelihood is dependent on the water at the downstream portion, and also there will be aquatic life that will be hampered. So that's why environmental agencies have fixed that if the river has such and such criteria, the water is flowing this many meter cube at the source, then at the downstream portion of also there must be certain minimum flow must be maintained to maintain the livelihood of the people around the river in the downstream region, and also the aquatic life, to maintain the aquatic life in the downstream region. So they will put some limit that you cannot withdraw water from the river beyond this level. So to maintain the environmental flow or ecological flow in the downstream region. So this is the concept. Okay. And multidisciplinary concept, I told that water research is basically a multidisciplinary concept. Okay. So let's see. Okay. So the explanation is, in the NWP or National Water Policy, drinking water is given the highest priority. So though the option 1 is correct by itself, but it was not a part about National Water Policy. Okay. As per the National Water Policy, the drinking water has been given more importance than the environmental flows, because national water policies, these national policies are made keeping the public demand in mind, right? So the aquatic life and everything, they are not giving to give vote, they are not going to give votes. That's why for such policies, drinking water, which is a public demand, it has been given the highest priority. But statement 2, the Water Institute should be restructured and made multidisciplinary. This is a correct statement. It is stated in the National Water Policy. Okay. So next MCQ is, Jal Jeevan Mission aims to provide piped water supply to all the households across the country by option A 2024, option B 2030, option C 2032, and option D is 2022. Okay. So the explanation is, the Jal Jeevan Mission aims to provide safe piped drinking water to all the rural households across the country by 2024. This scheme also covers government schools, Gram Panchayat offices, and CHCs, which are basically community health centers and Anganwadi centers. So this community health center or CHCs is a new concept in India. It is launched under the Ayushman Bharat scheme. So this is basically a kind of rural hospitals, and I am proud to say that my wife is a community health officer, CHO, who is an in charge of such community health center in the South Chobbish Pargana district of the state of West Bengal. So I actually came to know that actually there are hospitals, regular hospitals in towns, but in rural areas, the advantage of hospitals cannot be extended. So that's why there are partial hospitals. These are called the Sushastro Kendras or community health centers. So they provide medical services to the rural people of India. Okay. So now our next. So the Jal Jeevan Mission, the answer was 2024. Within 2024, within this year only, the Jal Jeevan Mission aims to provide piped water supply to all the households across the country. Okay. Next MCQ is recarbonation is required to A. Increase the pH of water to acceptable levels. Option B. Decrease the pH of water to acceptable levels. Option C. Acts as a buffer medium around neutral pH, that is 7. And option D. Doesn't have any impact on the pH of water. So the carbonation, this thing I actually discussed in one of the MCQs today when I was recording at the initial class. So the carbonation basically it is carbon dioxide is dissolved inside the water and forms carbonic acid, which is basically detrimental. Any kind of acid is detrimental to carbon, calcium oxide, or things made of metals. So they are corrosive in nature. So you can imagine if decarbonation is done, what will be the if decarbonation is done, what will be the nature of the pH of the water that you can imagine. So please give me the answer. I'll wait for 2 minutes. This is a conceptual question, not a memory question, memory based question. Okay, so I'll proceed with the answer. So decrease the pH of water to acceptable level. This is why the recarbonation is required. Now next MCQ. In the Central Groundwater Authority or CGWA notified critical areas, groundwater development is regulated by A. Concerned deputy commissioners or district magistrates, B. Secretary of Irrigation Department of concerned areas, C. Principal Secretary of the concerned states, and D. Municipal or Panchayat authorities of concerned areas. Okay, so I'll move on to the answer. So the explanation is, for enforcement of regulatory measures in notified critical areas, concerned deputy commissioner and or DMs, that is district magistrates, have been directed under Section 5 of Environmental Protection Act 1986 to regulate the groundwater development in these notified areas. So the concerned DMs or district magistrates or deputy commissioners is the regulatory body of the groundwater for the groundwater development in the critical areas notified by the CGWA or the Central Groundwater Authority. Okay, so let's move on to our next, fill in the blanks. Corrosion of pipe may occur if water is dash with carbonates, whereas scaling in pipes may result due to water which is dash with carbonates. Option A, undersaturated and supersaturated. Option B, saturated and undersaturated. Option C, supersaturated and undersaturated. And option D is undersaturated and saturated. Corrosion of pipes may occur if water is at the hot saturation level with carbonates, whereas scaling in pipes may result due to water which is at saturation level of what with carbonates. That is, you have to mention the saturation level. If the carbonates in water, that may present in three saturations level, that is undersaturated, saturated and supersaturated, right? So if the carbonate water is saturated with carbonates, do you think corrosion or scaling will occur? What do you think? This is a conceptual question. I will wait for 2 minutes. Okay, so let's move on. So if we see that there is carbonates in saturated condition, then nothing will happen because water is called as the universal solvent. So water has reached its full capacity to contain the carbonates. Okay. Now let's say if water is undersaturated with the carbonates, so that means water has still ion holding capacity. So what will happen? The water will be flowing through some pipes or something, right? And it will corrode that pipe because ions from that pipe will come if it is a metallic pipe. The mineral holding capacity, due to the mineral holding capacity of water, it is unfulfilled. So that's why the ion will get corroded and that ion will come inside the water to make it saturated. Now let's say if it is supersaturated, so it is oversaturated with carbonates, and so that it means whatever the capacity, ion holding capacity or mineral holding capacity of water is there, it has exceeded that. So the excess amount of carbonate will get deposited and scaling will occur. So now can you answer? Also no? Okay, so it's, okay, so I move on to the answer. So basically, this is the correct answer. If the water is less than the saturated, that is undersaturated with carbonates, then corrosion of the pipes will occur because the pipes, the material of construction of the pipes will get corroded, and that will add to the water to fulfill its saturation capacity. And if let's say the carbonate is super saturated with water, I mean water is super saturated with the carbonate, then the excess amount of the carbonate that is there, that is causing the supersaturation, that will get deposited on the pipe, and the inner diameter of the pipe will get reduced as the scaling will increase. Okay, hope it is clear. So now next there is a problem. A flocculation chamber has 12-meter long and 0.25-meter wide paddles. Both the paddles are supported parallel to the horizontal shaft. The shaft rotation speed n is 6 rpm, that is rotation per minute. Center line of the paddle from the shaft is 1.8 meter. Coefficient of drag CD is 1.8. The ratio of the velocity of paddle with respect to the water to velocity of paddle from a fixed coordinate k equals to 0.75. The power consumption by shaft in watt rounded to nearest one decimal place is, that you have to calculate. Now it is a basically formula based problem. So if you know the formula, you will be able to calculate. If you don't know the formula, you have to memorize it. There is a formula for power, which is based on the power number, but it's a dimensionless number. But the power number and those things will not be discussed here. Only the power formula will be used. So I'll wait for 2 minutes. Calculate and give me the answer. Otherwise, I'll move on to the solution. So if I just tell you the formula. So power is given by this formula. P equals to half of CD into rho W into AP into VPQ. CD is given in the question, coefficient of drag. Rho W is given in the question, that is the density of the water, 1000 kg per meter cube. Now AP is the projected area. And VP is what? VP is the velocity of the paddle with respect to the water. So these data are given to you. So you just note down this formula. P equals to 0.5 into CD into rho W into AP into VP. Repeat whole cube, but power is basically directly proportional to the cube of velocity of paddle with respect to water. Velocity of paddle with respect to water, is it given in the question? So yes, rotation speed RPM is given. So from what you have to calculate the velocity of the paddle, or maybe K with the help of this you have to calculate. So I'll move on to the solution. Maybe after 1 minute I'll move on to the solution. So you have to wrote it down this. This is the dimension of the paddle. Length is 12 meter, breadth is 0.25. So if you multiply them, it will be around 3 meter square area. That will be their project area or AP. CD is given as 1.8. Rho W, you know, 1000 kg per meter cube. And with the help of these two, you have to calculate the velocity. And center line of this R is also given. R is the radius. So you know that S equals to R theta, V equals to R into omega, and if you do the acceleration v dv by dt, that will be equals to R into dv by dt, that will be R into uh, your omega square or something. So if that is the acceleration term in the angular acceleration. So that will be there. Angular velocity, if you just multiply the radius with respect to the angular terminology, be it a angle or be it a velocity or be it a acceleration, then you will get the term for the linear thing. And you can see the velocity of P, the velocity of paddle is basically your in a linear velocity of paddle with respect to water. Right? It is not a, I don't think it is a angular velocity or circular velocity. So what is the relation? Relation is Vp equals to K into 2 pi Rn. This is the formula. So K has been used, 0.75, it is given in the question. 2 pi is 3.14. R, that is the radius. That is the distance from the shaft, given in the question as 1.8 meter. And N, because it is in SI unit and N is in RPM, that is rotation per minute. So if there is 6 rotation per minute, then per seconds, how many rotations will be there? What will be the hertz or RPS? That is the SI unit. Rotation per second. It will be 6 per minute divided by 60 seconds per minute. So 1 by 10 or 0.1 will be your RPS or rotation per second or hertz. 0.1 into this thing. So into 2, that comes your 1.5, right? So 0.15 will be this thing. 0.15 into pi into 1.8, that will be your Vp, which is nothing but 0.847823 meter per second. So next, the projected area AP will be 12 into 0.25, that is 3 meters square. As I told, it is the length of the paddle and it is the breadth of the paddle. You just multiply them, and how it is shadowing the water, it is nothing but the projected area, 3 meters square. Because the paddle, the movement of the direction of the paddle, the direction of the movement of the paddle will be perpendicular to the flow of water, right? So you have to take the perpendicular area to the direction of the flow of water. That will be your projected area, basically. So now the power number, as the formula gives, will be 0.5 into CD, that is 1.8, into rho W, that will be 1000 kg per meter cube, into AP into VP cube. So AP will be your 3 meters square and VP will be your what is this? So VP will be your this one, this cube. So it came out to be 3290.6 watts. How these two came into the picture? Yes, because projected area has two sides, so that's why. So one paddle has two sides. That's why this came into the picture. Yeah. Thousand. VP is 2 into 3 and VP is this one. Yeah. Right. So if you simplify it, it will become something like this. So now the last problem of today's session. I told you I'll be letting you go at the 8:30. So the problem goes something like this: a water treatment plant in a town is proposed to be expanded. So it is a brownfield project. So whenever there is a new plant that is being established, that is called as greenfield project. And if there is a capacity expansion of an existing system, that is called as the brownfield project. The new design flow rate is 1 meter cube per second. A deep bed granular sand filter with a design loading rate of 600 meter cube per day per meter square is to be used. If the area of each filter box is limited to 50 meter square of surface area, how many filter boxes are required? So if the answer comes in fractions, you have to answer to the nearest integer. Now it has another part. If one of the filter boxes is out of service, will the new loading rate exceed the design loading rate of the filter? This is the question. So I'll wait for 5 minutes. Please calculate and tell me the answers. So in the question, what do you need to do is basically you have to find the total surface area. If you are able to find the total surface area and then you will divide it simply by the area of each filter box, then you will get the number of filter boxes required. So if the total area is, let's say, A, then A by 50 meters square rounded up to the nearest integer will be your answer of the first portion. How do you get the total surface area? So if the design loading rate is given, it is basically not loading rate, it is basically your flux, because meter cube per day is your rate per area is your flux. So I may correct it, providing a bracketed term here. It is your flux, not your area in that sense, not your rate in that sense. So loading rate within bracket, it is flux. Okay, so I will move on with the solutions. So flow rate is given as 1 meter cube per second, which is, if you convert it into day, it will be into 3600 into 24, so per hour per day. In this way, it will come out to be 8,60400, no, 8,64,000. So it will be 86,400, yeah, meter cube per day. Now, total area required, that will be 86,400 divided by 600 equals to 144 meter square. Do you understand how we are getting this? So it's basically the flow rate is given. Now you are dividing the flux. Sorry, you are dividing the flow rate with the flux. So the flux unit 600. It is given as meter cube per day per meter square. So meter cube per day gets cancelled out, and that meter square that comes in the denominator. So in this way, the total area required we are getting 144 meter square by dividing the flow rate with the loading flux. If you divide the flow rate with the loading flux, simply you will get the total area. Now the individual box area is given as 50 meter square, and you get in this way the number of filter boxes required as 144 divided by 50, which is approximately 145 by 50 equals 2.88, which is approximately equal to 3. So 3 boxes will be required. 3 will be the number of filter boxes required. Hope it is clear. Very easy question. Okay, now let's come to the next part of the question. That is your what was the question? Yes. So if one of the boxes is out of the service, so you have got 3 boxes are there. 2.88, which is approximately equal to 3. 144 is the total area A divided by 50 meters square, which came out approximately 3. If one of the filter boxes is out of service, that is 2 is working, will the new loading rate exceed the design loading rate of the filter? So what is the design loading rate? The design loading rate is 600 meter cube per day per meter square, and you have to calculate the new loading rate to check whether it is exceeding the design loading rate of the filter or not. Now you can see one of the filter boxes is out of service. So total area that is available to you is not 144 now. It is 100, right? So if one of the boxes is out of service, then n, that is the number of available filter, is n 3 minus 1 equals to 2. Area of the filtration provided by the 2 filter boxes will be 2 into 50 meter square is equals to 100 meter square, because you can see in the question it is given individual filter boxes having the area of 50 meter square. So two filter boxes will be having 100 meter square. Now you have to calculate the loading rate with respect to the area. So loading rate will be basically nothing but the loading flux. Again, here you can mention flux here. So it will be something like this. So loading flux will be equals to 86,400 divided by 100. 100 is your area, right? Area of the total filter boxes, and flow rate divided by the area equals to gives you the loading flux. Now this is nothing but 864 meter cube per day per meter square, and the design loading rate is given as 600 per meter cube per day per meter square. So it is clear from the question answer that if the one of the filter boxes is out of the service, then the loading rate that we will get, that will be more than the design loading rate. So that means the filters will be overloaded, right? So three, if someone tells you what should be the design, so if you are the designer, you have to keep four boxes. So if one is out of the service, that doesn't become overloaded. So if one of the boxes are out of service and you are repairing that box, then you have to keep it in a 3+1. That is, one is in standby mode. If one of the three boxes becomes out of service, then you switch on the other one, and again it will be maintaining three. So the loading rate will be less than the design loading rate, 600, right? And again you repair that one, and again you keep that in standby mode. So it will be 3+1 will be the correct design. Okay, so hope it is clear today's class. If you are having any question, you can ask. Otherwise, we will be ending the session, because today is my last session. So if you have watched my recordings, the earlier class recordings and earlier class slides, so if you are having any doubt on that, you can ask. Otherwise, I'll end the session today. And the next two sessions, there are other two TS who will be taking. One will be taking the session in Tuesday, and another one will be taking the session in Friday. So you can attend any one of the two sessions. So for the rest of the lectures. So there are 2 weeks lectures are left. Maybe 1 week's lecture has been already uploaded, I think, right? So if you have watched that lecture of Dr. Bhanu Prakash Belangi, and if you are wondering how to solve the questions related to the assignments, you can watch the two TA sessions. One will be on Friday and one will be on Tuesday, 7 to 9 p.m. in both the days. You can watch any one of them to clarify your doubts for solving the assignments. Okay. So I hope there is no doubt. So let's close the session. Goodbye.